antiderivative of functions and antiderivative using substitution and integrals. Okay. So as always, so let's start with the learning outcomes. So after the lesson, so hopefully you can illustrate the antiderivative of a function, compute the general antiderivative of polynomial functions, root functions, exponential functions, trigo functions. So basically different kinds of functions kung paano kunin yung antiderivative class. And then also, we will discuss the basic technique on how to get the antiderivative. So we will use integration by substitution, okay? And also using a table of integrals. So let's start. So integration. So before we start class, so we have here an activity. So mabilis lang naman. So matching type, match the functions in column A with their corresponding derivatives in column B. So ito yung mga functions, ito yung mga derivative. So capital letter F yung functions and then derivative are the small letters. So kuha lang tayo ng dalawa. So what is the derivative of this one? Number 1. Number 1, so ano yung letter dito of the derivative? For number 1 class, ano yung derivative dito? Power rule. So these are polynomial functions. So derivative of this one is 3x squared plus 4x plus 1. So letter G. And then number 2, so 3x squared, ito yung isang may 3x squared, plus 2x plus 1. Okay? So ito yung na-discuss natin before class. So we are given functions, so these are polynomial functions. And then we will get the derivatives, right? So for integration class, ito yung given natin. So these derivatives, and then we will get yung ito, yung sa column A. So pabaliktad siya. Okay? Therefore class, integration is just the inverse process of differentiation. So it is also called, kaya nga tawag is anti or anti-differentiation. So kabaliktaran lang. Okay? Again, so given ito class, yung small letter f, we will get the capital letter F. So yung, kumbaga yung function, yung sagot sa integral class or yung antiderivative. Okay? So from the word integral or integer class, so it means whole, di ba? So ibig sabihin, di ba, from the derivative is actually synonymous into change. Na-discuss natin yung rate of change, di ba? So nagsasubtract tayo dito. Ngayon, ibabalik natin siya dun sa dati. So we will make it again as a whole. That's why yung word na ginamit is integral din. Okay? So from the word integer as a whole. So balik siya dun sa original function. So that is our introduction class. So again, integration is also called, so pareho lang yan. Pag sinabing integration, that is also anti-differentiation. Diba? So inverse siya ng differentiation or yung getting the derivative. So sa integration class, getting the antiderivative or integral para mas madali. Get the integral of this given. Okay, let's continue. So we have another examples here. So class, we have the antiderivative of this function, parang yung kanina yung small letter f. So kapag kinuha yung antiderivative niya, ito yon. So alam natin, let's check yung pabaliktad, di ba? Ito yung i-derive. So 12x squared plus 2x. So ibig sabihin, ito yung antiderivative. So pabaliktad. Okay? And then also here, antiderivative ng cosine x is sine x. Kasi kapag dinerive yung sine x class, we have cosine x. Okay? But take note class, the antiderivative is not unique. Bakit? For example, ito class, from here, di ba, ito yung integral natin or antiderivative, yung 4x cubed plus x squared. Ngayon, lagyan natin siya ng constant. In this case, minus 1. Kapag dinerive ito class, ito pa rin siya, di ba? We all know that the derivative of a constant is always 0. So ito pa rin siya. Ngayon, kung plus 1 ito, walang effect. Kasi kapag binaliktad mo nga siya, pag dinerive mo ito pa rin siya. Kasi derivative of a constant is 0. Therefore, class, so any constant na ilagay mo dito, i-add or i-subtract in this, for this matter, so yung sagot is ito pa rin. So let's say, i-represent natin yung constant as plus c. So ibig sabihin yung plus c is, pwede siya kahit anong rational number. So c is an element of real numbers. Real numbers pala class, not rational. Real numbers. Okay? So ito yung ibig sabihin nun, is not unique. Kasi pwede kang maglagay, mag-add ng different constant. So the same pa rin siya. Okay? So kung generally, kapag kumukuha tayo ng indefinite integer class, naglalagay tayo ng plus c. Kasi kapag dinerive ito ulit, 12x squared plus 2x plus 0, ito pa rin siya. Dun sa kanina, yung integral ng cosine x is sine x. So pag maglalagay ulit tayo ng constant, so iba-iba. So pwedeng iba-iba yung constant na ilagay. So the same lang din kapag binalik mo siya, kapag dinerive mo. Okay? So plus c, ilagay natin. Plus c to represent. Okay. So we have here, class, take note, antidifferentiation is the process of finding the antiderivative. Okay? So kabaliktaran ng differentiation. Ngayon yung symbol natin class is the integral sign. Ito. And then yung f, yung kanina, is integrand. Yung ini-integrate natin is the integrand class. And then if this capital letter F is an antiderivative of the small letter f, we write this one. So yung integral nga class is yung capital letter F or yung original function. Diba? Then plus c to denote constant. Ngayon, kung mapapansin nyo class, laging merong dx kasi nga kailangan kasama dun sa equation yung diniderive mo para ma-integrate mo siya. Kaya kailangan nandito si dx. So kailangan nandun yung derivative ni x to get the integral. Ngayon class, yung may plus c is what we call general antiderivative. Okay, kasi general siya. Ngayon, yung mga merong, let's say maglalagay ka ng specific number or constant plus 1, plus 2, those are called particular antiderivative. So depende na lang sa'yo kung anong ilalagay mong constant. Okay? So let's discuss the antiderivative of the algebraic functions class. So let's recall, ito yung mga derivative natin before, di ba class? Derivative of x. So this is the symbol of derivative in this case. So derivative ng x is equal to 1. And then we have the power rule class. Subtraction sa differentiation. And then kapag may kasamang constant, so ilalabas lang yung constant. And then the sum and difference rule. Okay? Ngayon, paano yung pagkuha ng antiderivative sa algebraic functions? So counterpart nila class, so integral ng dx is equal to x. Dagdagan ng plus c. Okay? Kasi nga binaliktad lang class. Okay? So derivative ng x, di ba, is 1. Ngayon, naglalagay tayo ng dx to represent derivative. Ngayon class, ito, yung kabaliktaran nito, we have power rule here, di ba? So tawagin natin ito as power formula para maiba lang siya. So kapag nag-integrate class, addition. So it makes sense kasi nag-minus tayo to get the derivative, di ba? Ngayon, para ibalik siya sa dati, you will add. So plus 1, n plus 1 in this case, and then copy lang sa denominator. Okay? Just like tong power rule class, ito laging ginagamit din. Okay, so kailangan ma-master ito. Ngayon, kung merong constant, again, ilalabas lang siya. So in this case, you have to separate it outside the integral sign. And then proceed on getting the integral. And then, kung dalawang functions in class, so plus minus, again, just like here, diba, derive each function. So, sa integral ganun din. Okay? Ngayon class, take note, kapag multiplication ito, f of x multiplied by g of x, hindi i-distribute yung integral. So let's have an example later done. Eto. So determine the following antiderivatives of this, the following. So number 1, so integral ng 3 dx. So ilabas yung constant na 3, then integral ng dx. Integral ng dx class is x. Lagi nyo tatandaan yun class. Integral ng dx is x. Kasi nga derivative ng x is 1, and then to represent derivative is dx. So 1 multiplied by dx is dx. Okay? And then number 2, this one is simply power formula. Take note class, laging merong dx to represent derivative. Okay? Kasi ini-integral natin yung derivative class. Kabaliktaran lang. So plus 1, 6 plus 1 over 6 plus 1. So therefore, x raised to 7 over 7. Ngayon class, for indefinite integral class. Ibig sabihin, ito yung merong, yung mga equations lang, mga functions. So naglalagay lagi tayo ng plus c. Kasi nga yung na-discuss ko kanina, diba? And then yung number 3 class, 1 over x raised to 6 dx. So dito class, gagawin mo siyang raised to negative 6. Diba? Kapag ganito, pwede mo siyang itaas. Ngayon, magiging negative siya. Proceed sa power formula. So plus 1 plus 1. Kaya magiging negative 5 over negative 5. Ngayon, kung negative siya, para maging positive, di ba? Baliktad lang. Pag tinaas mo siya, negative. Ngayon, kapag binaba mo, from negative, magiging positive. Okay? And then add C. Number 4, for square root of u du. Ngayon, for square root class, equal lang siya kapag ginawang 1/2 yung power niya. Diba? Equal lang yan, class. Ngayon, i-separate yung constant. So, magiging power formula ito, plus 1, and then copy lang yung power. So, 1/2 plus 1. So, this will be 3 over 2 over 3 over 2. And then, reciprocal ito. Kaya magiging 8 over 3 plus C. Walang problem, class, if nag-iba yung variable. Yung standard lang kasi natin is yung x. And then number 5, so sum of two functions. So distribute yung integral class. And then separate the constant. So magiging 12x squared in dx and then 2x dx. So power formula ulit. Plus 1, so 3 over 3. Ito naman, plus, ito meron na siyang 1. Plus 1, 2 over 2. Okay? Ngayon, meron siyang 2 doon, so maka-cancel. So plus C. Okay? Ito yung sinasabi ko, class. What if multiplication siya? Common mistake, huwag i-distribute yung integral. Integral dito, tapos integral mo pa doon. That is redundant. Ang gagawin mo dito is work on the equation, class. So kung ganito, you can distribute yung t. So basically, yung gagawin mo dito, kailangan maging sum or difference siya of functions. Okay? So distribute yung t. So magiging 2t raised to 2. This one, distribute negative 3t raised to 3 over 2. Okay? And then proceed on integrating. So integral of h, dito muna pwedeng i-distribute, class yung integral. Okay, power formula plus 1. So 2 plus 1, 3 over 3. Then ito, plus 1, that is 2 over 2. So 5 over 2. And then 2 over 5. Diba? Inverse. Kaya magiging 6 over 5, class. Okay? Then number 7, ito rin, class, kapag quotient, hindi i-distribute yung integral, class. Okay? Hindi i-distribute yung integral for each sa numerator and sa denominator. So mangyari dito is you will transform it again. Simplify if necessary. So magiging x squared over x squared. X squared over x squared is 1. And then magiging 1 over x squared. Pwede mo silang i-separate, di ba? Ito, tsaka ito. So kung 1 over x squared yung, class, so magiging x raised to negative 2. Okay? And then proceed. Dito mo na pwedeng i-distribute yung integral. So integral ng 1 multiplied by dx is x. Then power formula. Plus 1. So negative 1. Copy negative 1. And then bring down minus 1 over x plus c. Okay? So we are done sa algebraic functions, class. Now, exponential and logarithmic. So recap, derivative ng exponential is ganito sila. Okay? Derivative ng e raised to x, e raised to x, a sa constant class then ln x. Ngayon, paano kapag integral? So ganito. Integral ng e raised to x dx, and mag-end ng 10 minutes class. Integral ng e raised to x, so ex, e raised to x. Integral ng e raised to x dx, ito. Take note class, these are like formula based. Okay? So sa setup naman ngayon, wala naman nag-check sa inyo if chine-check nyo yung mga formula. So you can always check the formulas, di ba? Then integral ng x raised to 1 dx. So that will be equal to 1 over x. So integral ng 1 over x dx class is ln absolute value of x plus c. Okay? So now let's have an example. Find the integrals of these functions. So for number 1, integral ng e raised to x plus 2x dx. So distribute kapag ganito class, plus or minus, distribute lang yung integral. Huwag niyong gagawin yun kapag multiplication. So you have to, yung example kanina, di ba, i-distribute. Pero depende dun sa sinusolve nyo. So next, ito muna pala. E raised to x plus 2 raised to x dx. So distribute. So using the formula class, integral ng e raised to x dx is e raised to x from the formula. Okay? And then integral ng 2 raised to x, again, formula, ibig sabihin yung 2 class is yung a. So ibig sabihin, 2 raised to x ln 2, kung ano man yung a. So kaya ln 2 class dito. And then add plus c. Okay, next. Integral ng 3 raised to x dx. Ganun ulit. Formula based class. So you just have to follow the formula. 3 raised to x, then over ln 3. Kasi yung a doon is 3. Letter C, 3 raised to x plus 1 dx. Ito medyo may ayusin ka lang. Kasi you can actually separate this one as multiplication. So 3 raised to x at saka 3 raised to 1. Diba? Kasi pag ganito, you will add the exponent. Okay? So bali, nilabas yung 3 as a constant. So matitira is 3 raised to x. So again, using the formula, dito may constant siya. So 3, and then using the formula kanina class. So 3 raised to x over ln 3. Okay, again, we are following a formula. About this one, 2 over x dx. So we have here yung 1 over x dx class. So sineparate yung constant, pinactor out yung constant. So 2. Ngayon, merong formula dito, 1 over x dx. So we have ln and then absolute value of x. So ibig sabihin, ilalon lang dito. Ln x. Okay? Then add plus c. Okay. So ito class, we will discuss using yung integration by substitution. Okay? So we will go over these examples later on. Kasi we need to discuss yung integration by substitution. Okay, next. So we have trigo functions. Again, recap derivatives of different trigo functions. Again, these are all formula. Okay? Kapag hindi ito yung antiderivative class So, para lang meron kayong comparison. So, here are the antiderivatives. So, again, inverse lang sila. Okay? That is why integral ng sine is cosine. Integral ng sine is negative cosine, I mean. Then, etc. So again, formula. So let's have an example. Letter A. Integral ng cosine x minus sine x dx. Again, distribute muna yung integral sign. Integral ng cosine class is sine x. Minus integral ng sine is negative cosine. Kaya minus cosine x. Plus c. Okay, so negative, that is plus. Don't forget the plus c. Next. How about the integral ng cotangent square x dx? Ngayon class, since wala sa formula yung cotangent square dito, so we can actually think of, let's say, if possible, na meron kang magamit na identity, trigonometric identities, para merong lumabas na integral. So in this case, we can use this identity class. So cotangent square x is equal to cosecant square x minus 1. Ngayon, distribute the integral. Ngayon, meron ng cosecant square x na integral, which is negative cotangent x. Okay? So, kaya integral ng cosecant square x is negative cotangent square. Nawala lang si x dito. So, merong x yan. Then, minus integral ng dx is x. Okay? Then, plus c. Okay? Next, how about integral ng tangent square? In this case, v dv class. Ngayon, wala ulit tangent square dito. Pero meron sa identity is equal to secant square minus 1. So we can use that. Then distribute yung integral. So secant square, integral ng secant square, meron na dito, which is tangent x. And then integral ng dx or dv, in this case, is minus v. Okay? Again, formula. Then next, we have sine x over cosecant or cosine square x. Ngayon class, kailangan kumbaga i-manipulate lang yung equation para merong lumabas na integral na pwedeng integrate. So in this case, since cosine square siya, so pwedeng gawin ito. Ihiwalay yung dalawang cosine. So sine x over cosine x multiplied by 1 over cosine x. So pareho lang sila. Okay? So sine x over cosine x is integral ng tangent x. And then 1 over cosine x is secant x. And then integral ng tangent x, secant x dx class is sa formula. Ito. Secant x tangent x is secant x. Nauna lang si secant x dito. Okay? And then plus c. So kung mapapansin nyo class, wala dito sa formula si tangent and all the other trigo functions na wala pa doon. So we will discuss again using yung integration by substitution. So ito siya. So antidifferentiation by substitution and by table of integrals. So we have here class this integral x plus 4 raised to 5 dx. Ngayon, using the technique of substitution, we will sub this function, in this case yung x plus 4 as u. So gagawin natin siyang mas simple. Okay? So kung mapapansin nyo dito, yung mga x magiging u siya. So that is just the convention na gagamitin natin. Okay? So yung x plus 4, gagawin natin siyang u. So we let u is equal to x plus 4. Okay? So therefore, magiging u raised to 5 siya. Diba? Kaya ng substitution. Take note class, kailangan din pwede po ba yan gamitin sa lahat ng given? Depende. Okay? Yung mga kanina, direct, kumbaga direct na pwedeng magamit yung formula. So be careful lang sa paggamit ng mga formulas kanina. So there are cases na kailangan gamitin itong substitution. Okay? So kung as it is dun sa formula, ganun yung ayos ng function, so pwede nyong magamit. Ngayon, kung iba siya dun sa formula, kailangan munang mag-substitution para sure yung sagot. Okay? So, kung yung kanina class, so direct formula yan. So, depende dun sa ayos. Kung kamukha yung ayos niya, so you can use those formulas. Okay? Kung hindi, so use this substitution. So in this case, class x plus 4 raised to 5 dx. So again, we let u is equal to x plus 4. So magiging u raised to 5. Diba? Kasi x plus 4 niya is equal to u. And then do not forget, meron siyang dx. So kailangan din natin isub yun class. So paano natin makukuha si dx? So i-derive natin yung u natin. So pag dinerive yung class, that would be du over dx, di ba? Is equal to what? Di ba? Derivative ng x is 1. So derivative ng u with respect to x, ito. Kaya 1. And then cross multiply class, du is equal to dx. Actually, pwede dito, derivative ng u is equal to derivative ng x. Pwede rin yun. Para hindi nakakalito din. Tapos derivative ng of a constant is 0, di ba? So therefore, palitan din natin yung dx ng du class. So ito yung working function natin. Integral ng u raised to 5 du. So ibig sabihin, kamukha na siya class nung ayos nung mga formulas kanina. Ito yung sinasabi ko class. So we will transform it dun sa ayos nung mga formula. So u raised to 5, this is just power formula. Diba? So plus 1, so 6. Ngayon, 6 and then over 6 class. Ngayon, syempre, hindi naman ito yung magiging sagot mo. Ibabalik mo pa siya dun sa dati. Paano magagawa yon? So ibabalik mo siya since u is equal to x plus 4. So isasub mo lang siya ulit. So final answer is x plus 4 raised to 6. over 6. Okay? Then do not forget yung plus c. Another. How about this one? Ito class yung sinasabi ko. So kapag nakita mo ito, syempre you cannot directly use yung mga formula, di ba? So medyo kapag nakita mo, medyo complicated siya. So pag ganito, you can use or try, there are different kinds of integral techniques class or anti-differentiation techniques. Pero sa course nyo, yung kailangan nyo munang malaman is itong substitution. Other techniques like yung by parts, integration by parts, meron pang trigo, sub, so sa college yun. Okay? So ito yung sa ano nyo, sa course nyo, kumbaga, yung kailangan nyo munang malaman ngayon. So for this one, so yung u natin dito is x raised to 5 plus 2. So ibig sabihin ito. So very crucial class yung pagpili ng u. Kasi dun ma-determine kung possible ba siyang ma-integrate. So yung u mo is x raised to 5 plus 2 class. Kasi yung derivative ng u mo is 5x raised to 40x, which is nasa mismong equation siya. Diba? Kung ito yung ginamit mong u, para saan ito? Okay, so dapat ito yung u. Pag dinerive ito class, 5x raised to 4 dx. Diba? So therefore, we can directly sub. So magiging u raised to 9 du. Then proceed sa power formula. So plus 1, that is 10 over 10. And then palitan ulit from the dun sa sinab mo, x raised to 5 plus 2 is to 10 over 10. Okay? Okay, example number 3. So we have this integral ng z square over square root of 1 plus z cube dz. Ito class yung u niya is 1 plus z cube. So yung derivative ng u kasi is, so magiging 3z squared dito class. Derivative ng z cube is 3z squared. So with respect to z, kaya ganito siya. Okay? So kaya ito yung pinili na u class kasi kung mapapansin nyo, merong z squared doon, di ba? So para lumabas siya doon sa equation. Ngayon, kailangan natin siyang isub. So kailangan ayusin ito. So kuhanin yung z squared dz from here. Kaya magiging 1/3 du. Diba ito class? Du. So i-cross multiply mo muna. Ito, from here. Cross multiply. And then kailangan lumabas si z squared dz, diba? So du over 3, bring down si 3. Kaya magiging 1/3 du. Okay? Ngayon kapag ginayos siya class, integral ng 1 over square root of 1 plus z cube. So magiging 1, and then hiniwalay class yung z squared dz. Magiging 1 over square root ng u. Kasi ito class is u, di ba? Then isama yung square root. And then ito is this one. Kaya 1/3 du. Okay? Ngayon, factor out yung constant. That will be 1/3. And then u magiging raised to -1/2 since itong square root is 1/2, positive 1/2, and then kapag tinaas, magiging negative. Okay? And then ito, nasa ayos na ng power formula, kaya pwede na natin mag-add ng 1, so magiging 1/2, and then 1/2. And then inverse, or sorry, reciprocal nito is 2, kaya magiging 2/3. Then u raised to 1/2. So dinistribute yung constant. In this case, constant na 1/3 multiplied by C1. Ito yung litaw. Pero class, since constant rin naman ito, so we can actually change it as a general na C. So wala namang problem doon. Kasi constant din naman ito. And then, so we can now sub ulit yung U. That is 1 plus Z cubed. So this is the final answer. Okay? So another. Integral ng x over square root ng x squared minus 1. So yung u natin dito class is yung nasa loob ng square root. So x squared minus 1. Then derivative nito is 2x dx. Okay? And then kailangan sa equation, nasa equation is x dx. So kailangan makuha natin yung equation for that. So bring down si 2 dito. Diba? Para lumabas si x dx kasi x dx doon. Ngayon magiging 1 over 2 du and then 1 over u raised to 1/2. Kasi yung u natin is x squared minus 1. And then yung square root class is equal lang sa raised to 1/2. Do not forget. Then ilabas, factor out si constant. And then parang yung kanina lang actually, na example. So itaas, negative 1/2 para ma-power formula. Plus 1, that is plus 2 over 2 class, di ba? Kaya 1/2. 2 over 2 minus 1/2 is 1/2. Or 1 minus 1/2 is 1/2, di ba? Over 1/2. Then, reciprocal nito is 2. Kaya ma-cancel. So, may 1 is u raised to 1/2. Kaya, isa-sub na lang ito. Then raised to 1/2. Okay? Next, for the exponential and logarithm or logarithmic kanina. So again, so ito yung mga formula kanina, di ba? Ito yung mga sinabi or kanina na sabi ko kapag na-discuss yung integration by substitution, doon natin sila sagutan. Okay? Kasi you cannot use directly yung mga formula kanina. Okay? So integral ni e raised to 3x. Ayan. So kailangan yung substitution dito. So u is equal to 3x class. And then du would be 3 dx. Kailangan isub din si dx. So kailangan ayusin yung equation. So dx equal to du over 3. Okay? And then tsaka mo siya isub. E raised to u and then du over 3. Diba? So ibig sabihin nasa ayos na siya nito. So kailangan muna siyang isub para maging ganito yung ayos. Diba? So you cannot use directly. Okay? So 1/3 yung constant. So i-factor out. Magiging e raised to u du. And then from the formula, So e raised to x. Diba? Kapag lumitaw na to, you can just put e raised to u. And since merong constant ito, so you have to include 1/3. Okay? So, meron siyang constant na 1/3 na lumitaw through substitution. Okay? So, kung direct mo siyang ginawa dito, using yung formula, so hindi mo makukuha na meron siyang constant na 1/3 na kailangan pang ilagay. Diba, class? So, you have to use substitution. And then, sa B, so yung u natin is 4x and then du is equal to 4dx. Then dx equal to du over 4. Okay? And then isub. Ngayon dito, meron din siyang lumitaw na constant, 1 over 4. I-multiply dun sa integral. Ito. So, 2 raised to u over log 2. Proceed dun sa formula. So, meron din siyang kasamang constant. Okay? So, dito inayos lang. Ginawang 1 over 4 log 2. And then, multiplied by 2 raised to 4x. Okay? And then, sa letter C, 1 over 2x minus 1 dx. So, u is 2x minus 1. Yung derivative ng u is 2 dx. And then get the dx, that is du over 2. Okay, and then sub. 1 over u, since ito is equal to u, and then du over 2. Then meron siyang constant, 1/2. 1 over u du, so pwede nang gamitin yung formula. Ito. So ln 1/2 ln u. And then ibalik ulit siya dun sa u. 1/2 ln absolute value ng 2x minus 1 plus c. Okay? Now, kapag try ko naman, ito class. So, meron siyang, kumbaga hindi lang siya basta x. Meron siyang 4 coefficient, di ba? So, you have to use substitution. Kung direct lang siyang cosine x dx class, you can directly use without substitution. Pero ito kasi, meron siyang, kumbaga, polynomial siya class, or in this case, binomial, 4x plus 3. So yung u dito is yung mismong function na kasama ng cosine. I mean yung nakadikit kay cosine, which is 4x plus 3. Derivative nito is 4 dx class coefficient. So hopefully hindi na nahihirapan sa pagkuha ng derivative class. Ito yung, so hindi pwedeng mauna yung integration sa derivative. Kaya na-discuss natin yung derivative, di ba? So sa integration, kailangan yung knowledge sa pag-derive. Okay, so 4 dx. And then, yung dx is equal to 1 over 4 du from here. And then isub, kaya meron lumitaw dito class na constant na 1 over 4. Cosine u du, and then ito, kaya nagsisub tayo para magamit directly na yung formula. You remember, integral ng cosine is sine u. And then merong constant ito, kaya 1 over 4 sine, and then ibalik na dun sa sinab mo, 4x plus 3. Okay? By parts na yon, Gerbert. Meron ba sa, I think wala naman sa course nyo. Yung by parts, I think sa college siya tuturo. How about this one? Integral ng e raised to sine x, cosine x dx. So yung u dito, class, is sine x. Okay? And then derivative ng sine x is cosine x. And then isub ulit. So e raised to sine x, magiging e raised to u, and then cosine x dx is just equal dun sa du. So e raised to u plus c. So yung u mo is equal to sine x. So ibalik lang dun. Okay. Now, for the integral ng tangent, yung kanina sinasabi ko, so we need to use yung substitution. Sa trigo-identities class, tangent x is equal to sine x over cosine x. So gagamitin natin yon. Okay? So magiging integral siya ng sine x over cosine x dx class. So yung u dito class is actually yung cosine x from here. And then yung du niya is, derivative nito is negative sine x dx. Which is nandito naman. So kapag inayos to, so magiging 1 over u, and then since sine x dx yung nandito, so magiging negative du. Okay? So, baba si negative, and then mapupunta dito. So, sine x dx is equal to negative du. Then, ilabas as a constant si negative. So, magiging 1 over u du. 1 over u du class is yung kanina, diba? Yung maglolon. So, negative ln absolute value of u. Yung u natin is cosine x. Kaya, magiging ganito siya. Ngayon, merong other integral for tangent. So from here, since yung property ng logarithmic class, pwede siyang ikabit sa exponent. Kung ano man yung nasa coefficient or nasa yun nandito na constant, pwedeng ilagay sa power nito. That is a property of logarithm. So negative 1. That is 1 over cosine x. 1 over cosine x class is equal to secant x. Diba? Reciprocal sila. Okay. So therefore, ito yung mga formulas class. So yung kinuha na lang natin is yung tangent x. Okay, you can actually get or derive yung mga kung paano nakuha ito. Cotangent is, di ba, tangent is sine over cosine. And tangent is kabaliktaran lang ng cotangent. So gagawin mo siyang cosine over sine to get this. Anyway, kahit hindi mo alam yon, you can use the formula. So ito yung mga formula class. So integral ng secant x dx is this one. Ln din siya. Cosecant x dx is this one. Okay? Another. Integral ng x raised to 4 secant x raised to 5 dx. So yung u natin dito class is yung x raised to 5. Since kapag dinerive yung u, that is 5x raised to 4 dx. Okay? And then kapag inayos to get yung x4 dx, that is du over 5. Okay? And then kapag inayos siya, so maging secant u du over 5. So meron siyang constant, 1 over 5. Secant u. So from the formula class, so you can use this secant u du. So wala namang problem class if u yung ginamit na class. These are just variable. Actually, pwede namang sa z, dz, di ba? Any variable or letter. So final answer is this one. Balik mo lang siya dun sa ginamit mong u. Okay? Then how about this? Integrals of inverse circular functions naman tayo, class. Itong mga integral nila is yung mga inverse. Kapag merong ganitong ayos kayong nakita, du over square root of 1 minus u square, that is equal to, yung integral niya is inverse sine u. And this one, kapag ganito yung ayos niya, integral niya is inverse tangent. Integral nito is inverse secant. Okay? Ngayon class, ito kapag 1 yung given dito. Ngayon, for a general formula, kung hindi man 1 ito, kung hindi man 1 yan, ito yung gagamitin mong formula. So let's say hindi 1 yun, let's say 2 squared, which is 4. So a is a constant here. So ito yung gagamitin na formula. Okay? Example. Integral ng 1 over square root ng 9 minus x squared. So paano yung ayos nito? So hindi siya dito kasi hindi siya 1. So we will use, may square root pala siya. So hindi siya dito kasi hindi naman siya 1. So ito yung gagamitin natin. Yung general formula. Kasi 3 square yun class. Minus x square. Diba? Ito. Yung 9 square root mo, that is 3. So 3 square. Ibig sabihin yung a niya is 3. Therefore, ganito yung ayos niya. Yung sagot dito is inverse sine x, kasi x naman yung dito. Yung a mo doon is 3. Kaya ito yung sagot. Okay? Another. Integral ng dx over 9x squared plus 36. Dito class, kailangan mag-substitution. So u is equal to 3x. Square root nito. Kasi, di ba, 3x squared class is 9x squared. Derivative ng u is 3 dx. Okay? Then kapag inayos siya class, magiging du over u squared plus 36. Kasi 3x squared class is 9x squared. And then yung dx dito is du over 3, kaya merong 1/3 doon. Okay? So 1/3 factor out. And then using the formula dito, ito yung ayos niya, di ba? So 1 over 6 kasi 6 squared doon. Ito, 6 squared. So 1 over 6. Inverse tangent u over 6. Ito. Diba 6 squared to class? So yung a niya is equal to 6. Okay? So final answer would be 1 over 18 inverse tangent 3x. Yung u natin is 3x over 6. 1 over 18 inverse tangent x over 2 plus c. Okay? Another, yung last na inverse second. So yung u dito class is ln x. Derivative ng ln x is 1 over x dx. Ngayon, mapapansin nyo dito, meron ng dx over x. Diba? So ibig sabihin, yun na yung du. And then meron dito ln x, yun yung u natin, diba? So yung i's niya magiging u square root of u square minus 9. So yung i's niya is for this one. So magiging 1 over 3 kasi yung a nito class is 3. 3 square. Diba? Is 9. Saan na ako? 3 square is 9. Kaya 1 over a, which is a natin is 3. And then u over 3. Yun sa formula. Yung u natin is ln x. So papalitan mo siya. Ln x over 3. Okay? Then plus c. So summary class. Ito lahat ng kailangan yung formulas.